Bismillahirrahmanirrahim. Assalamu alaikum. Good morning to my dear students. I hope you will be having a very nice day today. Weather here is very pleasant, and we are going to start exercise 1.7. 1.7. It is very easy exercise, but we are coming up with one more definition or one more number, and that is composite number. So, to recall, I must once again tell you that what are the prime numbers. So, I already told you about the prime numbers several times, but this exercise consists of the prime numbers. Therefore, I am going to recall once again the prime numbers. So prime numbers are the numbers which have only two factors, and one factor is 1 and the other factor is the number itself. So for example, if I take 1, you see that 1 has only one factor, so we cannot take 1 as prime number and 1 is not the prime number. So I rub it off. So the prime number starts from 2, and this is the only even number in the prime numbers. So you see that 2 is divisible by 1 and 2 itself, and no other number can divide 2 wholly solely. So is 3 and 5 and 7 and 11 and 13. If you see 7, 1 and 7. If you see 13, 1 and 30. So this 13, this 11, this 7, and all the prime numbers are not divisible by any other number except the two, 1 and the number itself, 1 and the number itself, 1 and the number itself. Now what are the composite numbers? Composite numbers are the numbers which have more than two factors. These are the integers and that have more than two factors. Let us say, for example, 4. I have taken 4. Now, how many factors can I have? That are 1, 2 and 4 itself. Now you see, I have got one additional factor and that is 2 apart from prime numbers. So 4 is a composite number. Similarly, I can take 20. So what are the factors? 1, 2, 5, 10, 20. So you see, this is again a composite number. So this is composite. This is prime number and this is composite number. So let's start with the exercise now. One thing more, I must tell you that I told you that 1 is not the prime number and 1 is not even the composite number, because I have already told you in its definition that it has more than two factors. Let me write it. More than two factors. More than two factors. So 1 is again ruled out from here. 1 has already been ruled out from here. So question number 1, exercise 1.7. What does it says? It says which is the only even number which is also the prime number. So I have already told you, but to solve the question number 1, it is 2. It is the only prime number which is also the even number. None other number is even number in the list of prime numbers. Question number 2 says odd numbers which are also the prime numbers. which are also the prime numbers and be less than 50. So I have to write odd prime numbers. I can say it like this: odd prime numbers less than 50. So I have to only skip 2 from this list. So 3, it starts from 3, 5, 7, 11, 13, 17, 19, 23, 29. So my dear students, this is the complete list of the numbers which are less than 50 and odd prime numbers. Now, what the question was that how many odd numbers? How many odd numbers? I don't have to share the list in my answer. This is all rougher. This is all rougher. Now I have to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. Now the answer is 14. For question number 2, the answer is 14. There are 14 odd prime numbers less than 50. Let's proceed to question number 3. Now there are two parts of question number 3. Part A, and what does it says that now I have to list the composite numbers. Composite numbers which are greater than 4. Composite numbers greater than 4 and less than 30. Composite numbers greater than 4, less than 30. So what is the answer? You know that prime numbers are not the composite numbers. So I have to skip all the prime numbers from here. From this range, I have to skip the prime numbers. Rest are the composite numbers. So first composite number is 5. No, 6. Because 5 is the prime number and prime number have only 2 factors. And when there are 2 factors, that is not the composite number. That is prime number. So 6, not 7, 8, 9, 10, 11 again is prime number. 12, 13 again is prime number. 14, 15, 16, 18, 17 and 19 are prime numbers. 20, 21, 22, 23, 24, 25, 26, 27, 28. Now these are the numbers which are composite numbers and greater than 4 and less than 30. Greater than 4 and less than 30. Because 29 is again a prime number. What does the writer says in the question is, I'll read it to you. Try to write each composite number on your list as the sum of two prime numbers. For example, 6 is equal to 3 plus 3 and 8 is equal to 3 plus 5. We have provided with this list of composite numbers. These are all composite numbers. Now I have to write prime numbers which constitute our numbers in our list. But how? For example, he has given example as well that 3 plus 3 is equal to 6. Now this is prime number, this is prime number, and the answer is 6, and we have got it in our list as well. So we have to find such numbers from the prime numbers that can constitute by the sum, that can constitute or that can come up with the number provided in our list. For example, the next number is 8. Now this is 3 plus 5 is equal to 8. Both are prime numbers. 6, both are prime numbers, 8, and what about 9? So we can also constitute 9. See, both prime numbers, and we get 9. About 10. It is very simple. 5 plus 5 is equal to 10. 12. And similarly, we can keep on trying like this. 5 plus 7 is equal to 12. Again 14. 7 plus 7 is equal to 14. 15. 2 plus 13 is equal to 15. 16. 5 plus 11 is equal to 16. 18. 5 plus 13 is equal to 18. So my dear students, you can make all these possibilities. So I end up with this, but you can try yourself to get each and every number by the sum of a pair of two prime numbers. I proceed to the next question now. Question number 4. Now there are twin prime numbers. What are twin prime numbers? The twin prime numbers are the numbers which come head to head. That means which come one after another, and the difference is 2. For example, if I find the difference of 5 and 3, both are prime numbers, and the difference is again 2. And for example, 7 and 5, they come head to head, and the second condition is the difference is 2. So the both condition satisfies. That means the both example I told you are the twin prime numbers. For example, 3 and 5, 3, 5, 7, 5, and maybe 11 and 13. So these are all twin prime numbers. You can see the difference between the two is 2. The difference is 2. Difference is again 2. And difference is again 2. So these are twin prime numbers. Now I have to write all the twin prime numbers which are less than 100. Which are less than 100. So it is very easy question, and you can write it. 3 of them are already written over here. So next number is just write it in your rough column. All the prime numbers. See, 2, 3, 5, 7, 5, 7, 11, 13, 13, 13, 15, 16, 17, 18, 19, 20, 21, 22, 23. So my dear students, I have written prime numbers which are less than 100 in my rough work column. So you can see all these. You can also find these prime numbers from a mathematical table which was constituted by a Greek mathematician. You can find it in your book as well. So from 2 to 97 are the prime numbers, or these are all prime numbers. Now what I have to do, I have already written the first three. You see, they differ by 2, this differ by 2, and this differ by 2. Now 19 and 17 also differ by 2. 19 minus 17 differ by 2. Therefore, that means this is again the pair we needed. This does not differ, this does not differ. So 20, 29 and 31. 29 and 31. Next is 41 and 43. 41 and 43. 61 and 59. And then comes 73 and 71. And this was the last. So dear students, you can see that I have found all the twin prime numbers less than 100. These are 3 and 5, 7 and 5, 11 and 13, 19 and 17, 29 and 31, 41 and 43, 59 and 61, 71 and 73. I hope I will finish this exercise today, because only 2 questions are left. Now students, question 5 is that is 149 a prime number? If it is so, then how you have decided it? This is a logical question, and it is heading towards the test of divisibility. The test of divisibilities. Now first of all, what I do is I check it for 2. I check it for the test of divisibility. Is it divisible by 2? The last number is odd, so it is not divisible by 2. It is not divisible by 2. Now check it. It is divisible by 3. Just add all the digits. 5 plus 9 is 14. It is not divisible by 3 either. Now 5. What I told you, that the number ending on 5 and 0 will be divisible by 5 only. So it is not divisible by 5 either. So these 3 are ruled out. Now let me check it for 7. There are some rules for 7 as well, but there are not certain for the 7. So I go and check it in my rough column, and I check it for 7 as well. I know it is not divisible, but to confirm, you see that it is not divisible by 7 also. 2 comes as the remainder. So it is not divisible by 7. So my dear students, when it is not divisible by 2, it is not divisible by 3, it is not divisible by 5, it is not divisible by 7, then it is definitely a prime number. In question number 6, some information is given, and that is that there are super prime numbers. What are that? Super prime numbers. And what is the definition of these numbers? If you remove the unit side digit of that number, the number will remain as prime number. For example, 29 is a prime number. So if I remove the unit, what is the unit over here? 9. I just remove. So it becomes 2. So 2 is again a prime number. So 29 is super prime number. There are many other numbers which are all again super prime numbers. Let me do it like this. Now you see here again, by chance I got 9, and this is unit again, and if I remove this unit, it is again 23, and it is super prime number. So dear students, there are three parts in this question, but I advise you to do it yourself. And first is, I just give you the hint. First, question number 6, part A is find two 3-digit super prime number less than 400. You have to find a super prime number. You have to find a super prime number less than 400, and the digits be 3. It is very easy. So do it yourself. Can you find 4-digit super prime number less than 3000? And part B says, can you find the number less than 3000, which is super prime number? This is part B. This is part A, and part C says, now there is a telephone number written over here, 987 6413 6413. So I have to find that whether it is a prime number or not. So this is your task, and you must complete it. If you find any difficulty, you can ask me in the comment section below. So my dear students, it's time to sign off now. So have a nice day and goodbye.